As we have already discussed about the linear equation, identity, linear equation in one variable, solution of linear equation, plotting the graph of linear equation, about the quadrants, and more about how to find the points, expressing x in terms of y, y in terms of x, and all that. Now we must proceed towards something covering more. What is that? For the depth of the chapter, for what we are here. That is what? System of simultaneous linear equation in two variables. If two sets of linear equations are written together, then there comes something. It's like this. If I write x plus y is equals to 2 and 2x minus y is equals to 1. If I have written two linear equation in two variable together, this is equation number 1, this is equation number 2. It is known as the system of simultaneous linear equation. As in previous, we have discussed how to plot the graph of a linear equation. We know the graph of a linear equation is always straight. So graph of this equation will be one line, straight line. Graph of the second equation will also be the straight line. If I go with the method graphically, a very simple question comes that what? Number 1, if I ask you to plot the graph of first line and second line, how many situations can arise? 3. May possible that both the lines can intersect at a point. May possible that both the lines will never intersect, means parallel. May possible that both the lines are lying on each other, that is what? Coincident. So ultimately, whenever we have the system of simultaneous linear equations, then we have three situations while we are drawing the graph. May possible to be parallel, may possible to be intersect on one point, or may possible to coincide the lines. So with this, there are three good answers are coming. A, if two lines intersect, suppose their graph is coming like this shape. Suppose, say for example, these two lines are intersecting at a point. At a point intersection, this line individual have infinite solutions. Second line individually have infinite solutions. But when these two lines are intersecting at a point, it means that they have only one solution in common. Only one solution in common. This is known as, this situation named as unique solution, or consistent, or intersecting lines, or you can say consistent with unique solution. If suppose the situation is coming like this, that two lines are coming parallel. This line individual has infinite set of solutions. The second one is also having infinite number of set of solutions. They do not have any common solution because these two lines are parallel. So there is no solution, parallel lines, or we call this a special name as inconsistent. Suppose the third situation comes to you. What is that? In third situation, two lines are coinciding each other, overlapping each other. In this situation, these both lines has infinite number of common solutions. So from here there is an origin that what we have three types of solutions. Unique solution, another name is the consistent or consistent with unique solution, or intersecting lines. Second is if lines are parallel, parallel lines, no solution, or we say it is inconsistent. And the third situation, this is the situation number 1. I told you about this is unique solutions. The second one, it is the no solution, and the third one, it is the infinite solutions. This is the infinite solutions. So we can just tell by plotting the graphs what kind of situation is coming. Another name for unique is what? Consistent. Another name for no solution is what? Inconsistent. Another name for coinciding lines is infinitely many solutions is consistent with infinite. This is consistent with unique. Now we will discuss with you the algebraic methods of finding the solutions for the linear equations in two variables.